So in today's class, I'm splitting exercise 3I into three parts. So we already did part one yesterday, and today we'll do part two and three. So in this segment, we'll just look at inflation, and when we come back, period five, we'll look at credit cards. So you might not have heard of the word inflation. It has been in the news with cost of living. So really the key idea here is suppose you have $100. $100 can buy you a few things today, but imagine you go forward in time, maybe 20 or 30 years. What's going to happen is that $100 is not going to be able to buy you the same stuff that you could buy today for $100. And the reason for that is prices tend to go up. So, um, and the term that's used for this in business and economics is inflation. So I'm not going to talk about what causes inflation, but we just need to know that it's a thing, and that as prices go up, we can buy less with the same amount of money. Um, if you like, you might want to ask your parents how much they bought the house for or how much they paid rent for 20 years ago. It's going to be probably half of what the cost or what the price is now. And that's because of inflation. So in this exercise, our goal is to just give you a little bit of mathematics to analyze inflation at a very simple level. And the tool we're going to use for this is geometric sequences and geometric growth. So specifically, we will just use this formula. Capital R is 1 plus R over 100. We actually don't need to use a recurrence relation here. We're just going to use a formula. So is that okay? The value of money is not going to be the same. It's going to go down over time because prices are going up. All right, let's do an example. So I know I've just given you a lot of text all at once, so I'll highlight the key points. Let's imagine we're going to take a trip to the city. Maybe you're going to stop by Lynbrook train station, and when you're over 18 and you're not studying, it costs more. You don't get to pay the concession fare anymore. It's $5.50 at the moment. Now, $5.50 is not going to be the price in 10 years' time. What's going to happen is the government will raise the price, most likely in line with inflation, which is about 2.5% each year. So the question that I'm posing is, suppose we wait for 10 years. And let's assume that the inflation rate stays the same, about 2.5% each year. Can we predict how much this trip to the city is going to cost in 10 years' time? And the answer is yes. All we need to do is use the rule for a geometric sequence or a simple formula. So it's kind of simple enough that I'm just going to show you the calculation without getting bogged down in the details. So what we will do is we'll start with $5.50. That's our starting price today. And we're going to apply this growth 10 times. So I'm going to have some geometric growth factor, and I'm going to take it to the power of 10 because I'm applying it 10 times, once per year. All I need to do now is come up with the number inside the brackets. I need to find a way to increase a number by 2.5%. But we already know how to do that. We know that to increase a number, so this is just background, you don't have to write this. To increase a number by r%, we multiply by the factor 1 plus r, all divided by 100. So that's what's going to go inside the brackets here. And in this case, the inflation rate, R, is 2.5. Is that okay? So we're just increasing by 2.5%, and we're doing it 10 times. And we're doing that through multiplication. You can go straight to this step if you like, if you're comfortable with decimals. So 2.5% increase corresponds to multiplying by 1.025. And of course, we're taking this to the power of 10 as well. Now, at this stage, you will need to get a calculator. So go ahead and do it if you like. I'll do it on the screen. So 550 times 1.025 to the power of 10. Make sure your calculator is in decimal mode, otherwise it'll give you a really horrible fraction. So our prediction is $7.04. Any questions at this point? Can you give me a nod if you're following this and this is making sense? Okay, thank you. I will upload this right after we're done. So if you're not able to get everything down, that's fine, because I can upload this straight away. Okay, so it's all right. I'll just move on. Okay, we've got one more example and then we're done. So now I want to ask a slightly different question. Imagine I have $10,000 and let's say I fall into a coma for the next 10 years. Okay, it's not so good. And then I wake up. So what will happen is the $10,000 is going to be worth less. The purchasing power is not going to be the same 10 years from now as it is today. So the question that I want to put on the table is, how much could I buy in 10 years' time with $10,000 today in terms of today's money? So what I mean is, if I have $10,000 in the year 2035, what number goes here? So before doing the calculation, let's just think for a moment. Do we expect this number to be bigger or smaller than 10,000? What do you reckon? Yeah,
Smaller
smaller. Why?
because price has inflated to that in 2035. So
Yeah,
20.
that's right. So this is the price before inflation. And after 10 years, the inflated price is 10,000. So now we actually have to go backwards. Just now, when we did the train ticket calculation, we calculated the inflated price. Now we have the inflated price and we want to go backwards to figure out the original price, which is in today's terms. So there is a formula that you can use, and this is what is described in your textbook. I don't actually think you need it, but I've included it and explained it just in case you want to use it. So they define two terms: the current value, which is actually the money that is aging and not growing. So it seems counterintuitive because it's $10,000 today, but it stays as $10,000 in the year 2035. That's why it's the current value. And the sort of amount that has been adjusted for inflation that has gone down, that is the purchasing power. and the purchasing power is going to be less than the current value because time has passed. So we're going to call the current value A and the purchasing power P, and you'll see they are related by the same multiplication relationship that we used just now. So we'll finish with this example. So it's the same question, just worded differently. So I'm going to have to assume that there's some inflation, and I'm going to just guess that it's 2.5%. I'm going to assume that I have $10,000 and I want to find the purchasing power 10 years from now. So this time I have some unknown number, which I will call P. P times 1 plus 2.5 over 100 to the power of 10 equals 10,000. So notice that now the unknown value is the number that's being increased. Before we calculated this number, now we have to do the other number. Now, here, there is no way to use algebra with the tools in general maths. If any of you are taking maths methods, you can solve this equation using a technique called a logarithm, but we don't study that in general maths. So for this question, we will have to use the CAS calculator. So if you have it with you, grab it out and use the solve function. You can call this unknown number P, x, and what you'll want to do is say x times bracket to the power of 10 equals 10,000, and then navigate the menu and solve for x. So I'll demonstrate it on the screen now as well. If you need help finding buttons like the power button and the multiplication button, I can come round in just a moment once I finish the video. Once you've typed in this equation, what you'll need to do is highlight everything and navigate the menus. So the sequence is interactive, advanced, and solve. If you used a letter different to X, you'll need to change it here. That's why I used X. And there's our answer. So 7,811.98. And if we round to the nearest dollar, it's 7812. So I know that this is a maths class, but I hope that there's a life lesson here too. If you don't invest your money and you just leave it lying around doing nothing, you wait 10 years, you've actually lost 20% of the value of your money. So if you can invest it either in, say, a savings account or shares or something, that might be better than just letting it do nothing because it's actually losing value over time. Okay, so I'll finish by saying I have now covered exercise 3I, questions 15 to 17, and the questions on credit cards 12 to 14 we will do next lesson. So I'll let you go back to what you were doing yesterday. You might still be finishing 3G and 3H. That's fine. Um, but now's your time to do some questions and just let me know if you need some help with the calculator. And I'll upload this now as well. Thank you.